Hey, welcome to our notes for writing trig functions, and on the front of the notes booklet you'll find formulas that you can use to identify the a, b, h, and k in our transformation form for trig functions, where f, the function, is either the sine, cosine, tangent, cosecant, secant, or cotangent function. To find the a, you're going to first ask yourself, has this graph been reflected in the x-axis? If no, then to find a, you take the absolute value of the distance between the extrema divided by 2. And if there has been a reflection in the x-axis, then you take that same amplitude and make it negative for the a in your transformation form. Then we identify the b value by taking the period of the parent graph and dividing it by the period of the graph that we're given. To find the k, we're going to find the average of the extrema, which is that midline. So we add the max and min and divide by 2. If it's a tangent or a cotangent function, remember those parent graphs do not have relative or absolute extrema, so instead you would use your turning points for that wiggle shape that goes either increasing for tangent or decreasing for cotangent. And then to find the phase shift, that's the h, we're going to graph the function and compare the features to determine the direction and magnitude of the phase shift, remembering that x minus h shifts the graph to the right, x plus h shifts the graph to the left. Okay, and we're going to use the TI-84 graphing calculator in this lesson. So if you have one, you can go ahead and grab it now and make sure that you're in radian mode. So in example 1, we're asked to write a sine function for the graph that's shown, assuming that there's been a reflection in the x-axis, which tells me that the a value is going to be a negative because there's been a reflection in the x-axis. Okay, and then a phase shift to the right if needed. So we don't know yet whether a phase shift is required in our function or not, but if it is required, the problem directs us to shift to the right and not to the left. So if I look at my graph and I want to identify my extrema, this sine curve has an absolute max at 5 and an absolute min at 1. So max minus min would be 5 minus 1, which is 4. And so a is equal to negative, and then 4 divided by 2 in absolute value is 2. So we're going to use y equals negative 2 for the a, and then the function is sine, and now we need to find the b. So to identify the b, we take the period of the parent graph, and the period of sine is 2 pi, and we divide that by the period of this graph that we're given. And the period would be the distance between max and max. So we're going from 0 here to 4 pi, so that would be the period of this function, 4 pi. So we're taking 2 pi divided by 4 pi. The pi's cancel and leave us with a 1/2. And so the b in our equation is 1/2. Okay, then that's times x minus, and then we'll leave a space here for the h in case we need one. And then we add the k, which is the vertical displacement. So to find that vertical displacement, we could, if we're looking just at the graph, identify the midline, which is halfway between the extrema. So we can see here on our graph, the midline is at 3 on the y-axis, so my k equals 3. But if I want to work that out using this formula, I would take my max, which we already identified was 5. Add the min, which we already identified as 1. And 5 plus 1 is 6, divided by 2 equals 3. So again, I can see that 3 from my midline on the graph, and that would be the k, which is 3. Now, to find if there's an h or not, we're going to use our graphing calculator. Okay, so we're going to pull up the graphing calculator and first check the mode. We want to be in radian mode. Then we're going to go to our, let me clear my memory here real quick, 712, second plus sine 722. Okay, so now that my memory is cleared, I'll check the mode. I'm going to go to the y equals, and in my y equals, I'm going to enter this equation that I just created, -2 sine of 1/2 x. And then I'm going to assume my phase shift is 0 and just add 3 for the displacement. And then in the window, I'm going to set my dimensions to match what's given in this graph. So my lower bound for x is -2 pi. My upper bound is 4 pi. The scale for the x direction, each of these tick marks, is pi over 4. Then lower bound for y is -2. Upper bound is 6, and the y scale is going by ones. So when I click on graph, I'm going to compare this graph with no phase shift to the graph that I was given. And if I do trace 0, I'll see my y-intercept here, which is at 3. But on my graph, the y-intercept is at 5. And remember, the instructions for this problem told me if I need a phase shift to shift to the right. So I'm going to shift to the right pi units, and that's going to put my point of intersection with the midline here at pi comma 3, which should match with what I want in my graph. So I'm going to make this a shift of pi units to the right. So now let's go back to the y equals here, and we're going to change this now to have a phase shift of pi units to the right. And then my vertical displacement was 3. And then we'll hit graph and compare this y-intercept now. So I'll put 0 in for x, and there's my y-intercept at 5. Now let's see if the minimum is correct. If I type in 2 pi for my minimum, I get 1, right, which matches 2 pi comma 1 for the minimum. If I put in 3 pi, I should get back a 3 because that's where the midline is. So let's type 3 pi for x, and there it is. There's my 3 for the y. So now I know that this equation checks because it matches the graph that I started with. Okay, so go ahead and pause the video, and I'd like you to try writing this cosine function from the graph by yourself based on what we learned about writing the sine function in example 1. And then once you've identified the max, the min, the period, the reflection, A, B, H, and K, write your equation and then turn the video back on, and we'll go over the answers together. Okay, so we can see from the graph that there is an absolute max for this cosine function here at -2. And we've got an absolute min down here at -8. And the problem tells us to use a cosine function assuming no reflection, which tells me that my A is going to be positive once I find the absolute value of the max, which is -2, minus the min, which is -8. And two negatives make a positive, so I have -2 plus 8, which is 6, divided by 2, which is 3. So my A is equal to 3. Okay, then to identify identify the period, I take the period of the cosine parent graph, which is 2 pi, and I divide that by the period of the graph that I'm given, and I can find that period by going from max to max or from min to min. Okay, and I can see starting at 0, I have a period here of pi over 2. And it's weird to look at a stacked fraction like that. It's easier to think of this side by side. So 2 pi divided by pi over 2. Remember, when you divide by a fraction, you multiply by the reciprocal. So that's 2 pi times 2 over pi. The pi's cancel and leave us with a 4. So b is equal to 4 in this equation. Okay, next we're going to look for the vertical displacement, and that comes from the midline of the graph, which we can visually identify here at -5. Or you can calculate it by taking the average of your extrema. So if we take this k vertical displacement and set that equal to the max, -2, plus the min, -8, divide that by 2, we get -10 divided by 2, which again is -5, and we can see that -5 from our midline on the graph. Okay, so we found the period, that was pi over 2. The reflection question was a no, because it was stated in the problem that we're assuming no reflection. And then it tells us to assume that the phase shift is to the left if one is needed. To determine if one is needed or not, we're going to need to sketch the graph of what we've got so far, which is y equals a, that's 3, cosine of the quantity, and then our b is 4, x, and then minus, oh, I forgot to leave my space for the h. 4, then x minus, we'll leave a space for h, and minus 5 is the k. So we're looking to see what the h would need to be. And since it tells us that any phase shift would be to the left, we're going to make that a plus, because our phase shift would have to be x plus the value to go to the left. So let's pull up our calculator, and we'll enter in the equation that we just wrote, 3 cosine of the quantity 4x minus 5. And then I'm going to go to my window and change the dimensions to match the graph that was given. So that was a lower bound of -pi, an upper bound of 2 pi, going in increments of pi over 4. Then our y-axis is -8 to 2, going by ones. And we'll hit graph. Okay, and now when I go to trace and enter 0 for x, I see my y-intercept is at -2, but I need my y-intercept to be at -8. Now, the -8 is a minimum, the -2 is a maximum, and if I have to phase shift to the left, like the problem says, then that means I'm going to need to go, oh, lost my graph, I'm going to need to take this point, right, and I'm going to need to move it to the left pi over 4 units, so that this -2 is now on, would now be on the y-axis. So I'm going to make that phase shift pi over 4. So now let's go back to our equation in the calculator, and we'll have a parentheses after the b, then x plus pi over 4. Then our vertical displacement is a -5, and we'll click on graph. trace again and now test it out. So if I put 0 in, I should get back my -8 for the absolute minimum, which I do. If I enter pi over 4 for my x, that should return -2 for the y. That's my absolute maximum, and it does. If I enter pi over 2 for the x, that would be my midline. Or no, pi over 2, I'm sorry, would be -8 again, a minimum, which it is. To get to the midline, I would need something between those two. So pi over 8 would be between 0 and pi over 4. So let's do pi over 8 and see if we get the midline at -5, and we do. So now we know that this is the equation of the graph that was given.